Hey, Y11, or should I say Y12? Hey guys, so today we're going to be doing a run through of the exam paper that you guys did for GCSE. Very interesting set of results. Definitely lots of discussion that needs to be had about it. I'm going to be going all the way through it today, making sure that you guys, I'm just going to put the light on so you guys can see that. I'm not going to make it. There we go. There we go. Okay. I also realize I have to do the register. So I need to find the register. Just to remind people, so for anybody who hasn't had YouTube channels with me before, I'm also aware that you guys might need to turn up. So if you go to the little cog at the bottom of the YouTube video, you'll be able to raise the quality of the video up to HD. So it means that you'll be able to see this better. I know that some people didn't do that when I first started doing webinars. Anyone that knows me or has probably already done it, it might be worthwhile just fiddling around with the settings just so you guys have a quality of video. I'm trying to find out where eek, I can't find the register bit. That's a nightmare. Oh, he shared it with me and I've lost it again. It's frustrating. That's not going to be the register that I want. No, it's not. That's absolutely a nightmare. I'll do it retrospectively. Okay. I'll run the register on my document because I keep a separate one anyway. So I'll do that now. Sorry guys, hang on one sec. Okay, so register for today. Let's have the date. Today is the 15th of the 5th, 2020. Okay, so do I have Adam? Is Adam in the house? Is Adam in the house? No Adam yet. I've got Angel. Good to see you, Angel. Thanks for coming. Got Anch. Aisha? Do I have Aisha? No, not yet. Do I have Alistair? Where's Alistair? No Alistair yet. I've got Isha. Good to see you. Emmeline. Do I have Emmeline? No, I haven't got Emmeline yet. Hermione. Where's Hermione? I haven't got Hermione yet either. Do I have Meryl? No, Meryl. Oh, there's Meryl. Yay. Do I have Manisha? Yeah, got Manisha. Minwee? I still think I saw Minwee. Yeah, there she is. Got Misha, seen her. Got Murdo. Nick Chan, I know, is not going to be here now because he's doing something else. Julian, I think I've seen. Yeah, got Julian. And got Oliver. Yeah, got Oliver. So still waiting on Adam. And I know that I'm just going to quickly check to see whether or not anyone's posted on the Hangout chat, just because I know that people are going to be. Anyone who hasn't. Oh, okay. So I think everyone looks like they've read it. Alistair is here. He just doesn't have a YouTube account, so can't comment on the chat. Tell Alistair to sort out his YouTube account. I do need him to be able to contribute on the chat. That is important for me to be able. Oh, Alistair sent me a request. Lol. Yeah. I'm here. Oh, okay. Alistair, can you please just activate your YouTube channel just so you can contribute on the chat? I would appreciate that. Sir, I think I have the wrong YouTube channel. Yeah, search for Tobias Duncan rather than. Oh no, search for Toby Duncan, not Tobias Duncan. That's why. I've got an old one that I can't remove because it was the old one that I had through school. That's nice to see that Adam's here as well. It's great. See if you can track it down, Adam, and then pop on. Alistair is here. I'm still missing Aisha. Anyone seen Aisha? If someone could message her, that would be great. I'm missing Emmeline and Hermione. In a minute, I'll start the run through, guys, even if they're not here in another 60 seconds, and then I can always add them to the register retrospectively. It's good. Yeah, because I can't flick between the Hangout, Alistair, and the YouTube. There's Hermione. Amazing. So I'll mark Hermione in. So still missing Emmeline and Aisha. If Seattle Merrill could send them a message, that would be great. That'd be very much appreciated. I'll leave it at that for now, and I'll crack on with the video. Right, guys, I do most of my lessons through YouTube. It means that I can keep them, and it means that you guys can review them as many times as you like. I like to think that people will go back and watch these time and time again in order to be able to develop themselves in chemistry. There is some value in that. Emmeline has connectivity issues, so she needs some time. No worries. Okay, thanks for letting me know. Adam is still struggling, I think, to find the chat. Oh, thank you, Sian, for sharing it. Yeah, thank you for sharing it. And then Adam should then appear on the chat. That's great. This is a very cool video, though. I love it. The fact that Adam's watching my other videos instead of coming to the current video. Lol. Okay, let's crack on, guys. So, can I say, first of all, I'm really pleased with everyone's results. Aisha is making her YouTube channel, so she should be here soon. Perfect. I want everyone to give a quick round of applause. You can do the clapping symbol on the YouTube chat to Julian and Nicholas Chan. They got the highest in the class. Well done at 17 out of 20. Great result. Really, really pleased. Julian, especially well done. I don't know Nick Chan very well, but Julian, I'm really, really, really proud of you. What a great result that is. That's great. Well done. Yeah, I'm so proud of you. That's such a great result. Right, let's crack on with the review of the test. Next lesson, I will also be on YouTube, and we're gonna start A-level calculations. I'm actually going to be teaching A-level calculations from a GCSE basis. I'm actually going to reteach you every calculation from ground up, and I'm going to be taking you guys up into that A-level level, the advanced subsidiary standard, get you guys all up to that point, but reteaching everything. That makes a lot more sense rather than making this big assumption that everybody is at the same point. Mr. Duncan, you have more subscribers here. Yay! Do I? Oh, amazing. To be on this channel rather than my other channel. I'd hope so. This one I've done a lot more videos for now. Okay, let's crack on, guys. Let's share screen. Share my screen. There we go. We're up. We're up and running. Okay. So, here was your test. Just to let you know, I will be making a third. I need to be making more and more of these online tests. They're so useful. I'm not going to be looking at the results too much of everybody on the actual data. Everyone has had their oh, look at that. There's Aisha. She's in the house. I'll put Aisha there. Well done. Nice to see you. Fab. Let's now get rid of that. Save and close. Right. Okay. So what I'll do is I'll just be talking you through all the questions, checking that you guys know what's going on, and then pointing out the common errors that I'm seeing across the board. Okay. So what is the formula of aluminium nitride? So this was answered fairly well across the entire board. It was really nice. Really happy with it. Yeah. So aluminium nitride. And the key thing here was the "ide." There were one or two people, I think actually only one person who made the mistake. Not to name any names. No, excuse me. Sorry, Meryl. But aluminium nitride is aluminium, and we get aluminium 3+ from the periodic table. Now, you guys are we're going to start switching almost immediately. I'm going to stick with the GCSE table today because it was a GCSE test, but this is going to be the last time we use this table. We're going to be making a transition over to the A-level table immediately. When I give you lesson number 1, we're going to be doing some chemistry 101, where I will be making sure that you guys have all the basics that you need before we can really start. And the first thing we'll be transitioning over to the A-level periodic table, but we're going to stick with this one today because we need it for our test. We've got aluminium here in group 3, so it's going to be +3, and nitrogen over here, which is 3-. Yeah, so I think majority of people got this right, which was really nice. Yeah, you do the clever X factor trick cross and down, where you get Al3N3, but then they simplify. We realize that in reality they cancel out to give us Alan. Love Alan. Alan's great. There we go. So there was the final answer for the first question. Nice, straightforward GCSE I'm just going to level some of these if I can as well. Try and do that in the margin. Yeah, so this was a lower level question. This is a level 2, 3, very low level, but you still need to be able to read the periodic table. Next one, everyone got this one, I think, which was really great. Name the compound. I'm suddenly realizing I want to do the answers in red. Yeah, definitely. So Alan, there we go. And so this one was a nice straightforward one, a good naming question. So this was calcium sulfate. No, sulfate, phosphate. There we go, calcium phosphate. And the key thing here is to underline the 8. Yeah, we realized that the two differences between these two questions was the I'd and the 8 one. But I think everyone in the classroom got that one right. I was really pleased. But however, only one person, just one person, got question 3 correct. Well done, Julian. Julian remembered. Why would I ask you to do 2 different names? Why would I do that? It makes no sense. Sir, why would it be diphosphate? Adam, it wouldn't be. The reason why is because this compound is ionic. Yeah, it's ionic, which means you don't ever actually need to put the di in there. It's carbon dioxide. You add the di because it's covalent. Yeah, simple covalent. But this is ionic, so we're not going to include a di. Good question, though, Adam. Glad you asked. Thank you very much. So, as I said, everyone except Julian got this next question wrong. So, by the way, the naming there was on a level 2, 3 again. And then there was a step up here to level 4. Yeah. And this is because vanadium is a transition metal. Lots of people didn't catch it. In fact, everyone missed it except for one person. Julian, so proud of you. Vanadium is in the transition metal block. Yeah, these are TMs. And if everyone in this room needs to know, yeah, you cannot forget to include your Roman numeral. Yeah, this is actually a level 4, 5. Just so you know. And what you had to say was most people put vanadium, most students put vanadium oxide. Yeah. Out of the 15 or so of you, I think about 12 of you put that. Yeah. The problem is this is not enough. Yeah. What you actually have to do is work out the charge on the vanadium. So the way that you do this, and this is actually part of redox from GCSE and A-level, more A-level. Yeah, we know that vanadium, this vanadium oxide, we've got 2 oxygen ions here. And we know everyone in this room needs to know their common ions. And we get it from the periodic table. Yeah, +1, I'm going to shrink my pen because it's way too fat for that. Shrink that, do it in red. Yeah, this is +1, +2. We're going to need a Roman numeral between 1 and 7, +1 to +7, yeah, and then it goes +3, then it's +4 or -4, then it switches over, -3, -2, -1, no charge for the noble gases. Oxygen is in group 6, so we know that the oxide ion is O2-, but there is 2 of them, yeah, so the total minuses is -4. Now, for this to have an overall charge of 0, vanadium must be bringing +4. And there's my Roman numeral. Well done, Julian. I was absolutely chuffed to bits to see at least one person get that right. This is vanadium 4 oxide. Well done, Julian, again. I'm so proud of you. What a great step up that was. Cool. So we will do a bit more naming when we go back to doing naming again. I'm going to run all these processes again with you, and I will be setting you guys homeworks every lesson to reinforce these slightly harder, these higher level questions. Okay, so next one, calculate relative molecular mass, RUMS, and I gave you hydrogen peroxide. Yeah, so this was a nice, easy question. Again, it drops down to a level 3. Yeah, so again, you had to read it on the periodic table. Hydrogen is 1 and 1, oxygen is 16 and 8. We all know here that the mass number is the top number. Yeah, that's the mass number. So I needed to count them. The first thing is I have got hydrogen at 1, but I have 2 of them, hence the 2. And then I'm going to add that to oxygen at 16 times 2. I'm going to do this on my calculator. I don't do anything, any calculations. I will never, ever, ever do it in my head. I don't care how good at maths you are. Yeah, you never, ever do those things in your head. Yeah, and I'm going to get an MR of 16 plus 16 plus 2, and I get an answer of 34. And we come to an end. Now I'm going to give you now the A-level part. Right, this is part of the A-level lesson, so I'm just going to drop it in here. At A-level, every AR and MR must be done to 1 decimal place. Students often ask why. The reason why is because if you look at the A-level periodic table, every single atom is now given to 1 decimal place, which means your answers must be given to 1 decimal place. But for GCSE, it was just 34. MVP Julian. I don't know what MVP means. Is it because I'm a boomer? It might be. Then a massive step up. This now jumps to a level 4-5. What I'm doing is I'm leveling the question, giving you an easy, stepping up to a harder. Yeah, so it now asks you for the relative formula mass. This tells me that the molecular is covalent, and the formulae tells me it's therefore going to be ionic. It's nice to see the difference. We have the three symbols, don't we? We have RAM, relative atomic mass, relative atomic mass. That's off the table, yeah. And then we have relative molecular mass. This is telling me that it's a molecule, yeah. Relative molecular, so it's a molecule, so it's covalent, yeah. And then we have relative formula mass, which tells me that it's going to be ionic. It's just nice to kind of go through those things. We'll cover it again in one of our lessons, so don't worry too much about it. But you had to do a much more challenging RFM. Yeah, now you have to realize that there were waters bound. This dot here, this is this compound. Oh, on the chat, please, impress me year 11. Or should I call you year 12? Can somebody please name me that compound, please, on the chat? Let's see how many people are in the room. I want everyone to contribute, please. I'd like to see that everyone's doing it. Even if you're copying other people's answers, it's not really the point. If you don't know, say you don't know, and I can always go over it again anyway. But put the name of that compound on the chat. Let's now add it up. I have sodium on the periodic table at 23, and I have 2 of them. I have 1 carbon at 12 times 1. I have oxygens plus 16 times by 3. Yeah, and then I have water. And you guys, hydrated sodium carbonate. Thank you, Manisha. Well done. Great answer. Oliver, well done. Hydrated sodium carbonate. Hydrated sodium carbonate from Ellen. There's a better name. There is another name for this, guys. And can I just say that I can't remember, it's very unusual for me, I can't remember the last time this was actually asked. There is an alternative name. I wonder if anybody knows it. Hydrated sodium carbonate is the simpler of the 2 names. Next, I've got water, and I have 4 waters. We know that water weighs 18 non-hydrated sodium carbonate, though that's called anhydrous sodium carbonate. Adam, and non-hydrated. No, non-hydrated means without water. Anhydrous means without water. Yeah, I know that's odd. That should say sans hydrous. Yeah, anhydrous, meaning without water. This is 4 times 18. Nobody knows it? This is sodium carbonate pentahydrate. That's what that's called. No, sorry, tetrahydrate. The proper name for that is sodium carbonate tetra, which is 4 in chemistry speak, tetrahydrate. Isn't that cool? Yeah, or hydrated sodium carbonate. Yeah. Aisha, thank you so much. Not without water, non-anhydrous. Yeah, we never would have gotten that. Funny. No, I know, that's okay. That's what A-level's about, Emmeline. Yeah. So now I need to total this up on my calculator. I'm going to put brackets exactly as I've written it. 23 times 2 brackets plus 12 plus open brackets. 12 times 1 close brackets plus open brackets. 16 times 3 close brackets plus open brackets. 4 times 18. The MR of water. You need to know that one, folks. So I get an MR of 178 at GCSE. At A-level, that would have been 178.0. It actually wouldn't have been, probably would have been 0.1 because sodium is 23.1. I think I might be wrong. Eek, sodium. I tell a lie. 23.0. It would have been 178.0. My bad. Nah. Next. Again, step up, stepping into a level 5 here. Percentage composition, starting with an easier, then getting harder. So I asked you then for a percentage of manganese in potassium permanganate. This was not answered well by the class. I definitely need to go back and revisit percentage composition. Now we know that the equation for percentage composition is wanted, wanted MR or AR, not wanted, wanted AR or MR, over total MR, total MR times 100 will give us the percentage. So what do I want? I wanted potassium, and there's one potassium in it. So I want excuse me, K39 over, oh, hang on, I tell a lie. My apologies. I wanted manganese. Manganese is 55. My apologies. So Mn 55 over K39 plus Mn 55 plus, how many oxygens are there? 4, plus brackets, oxygen at 16 times 4, times 100 will give us our percentage. I will reteach percentage composition since everyone found it a little bit tricky. By the way, I'm about to lose a mark at GCSE because you can't do that equation like that. You have to write down the total. I'm just going to check that the AR, that the relative atomic mass of manganese is 55, because I don't often see manganese, but there it is, it's correct at 55. 39 plus 55 plus brackets 16 times 4, and I get 158. There's my mark. So 55 divided by 158 times 100, 3 significant figures, 34.8%. I think some people rounded up on that one. Just going to check that. 39 plus 55 plus 16 times 4, 158, 55 over answer times 134.8. Done. Next, got harder again. So we now jump to a level 5, 6. At this point, it's going up a level. And now they wanted the percentage of water in copper 2 sulfate pentahydrate, or hydrated copper sulfate, copper 2 sulfate if you want. You need the Roman numeral because copper is a transition metal. Yeah? So, okay, wanted is water. Now, the most common mistake for these ones is the fact that people will do 18 over the total. You can't do that. We have 5 waters. Yeah? So 5 times 18, 18 is the MR of water. You need to learn that one. Over the total. And the total is Cu 63.5 on the GCSE table plus 32 for sulfur plus oxygen at 16 times 4 plus 5 times 18 plus 5 times 18, the MR of water. Total it up, 249.5, I believe. So 63.5 plus 32 plus 16 times 4 plus 5 times 18 gives me 249.5. There's the mark in my exam. I get the mark for that, not that. Reminder, yeah. So 90 over 249.5 times 100. 3 significant figures. 90 divided by answer times 100 gives us 36.1%. 3 sig fig. If you use rounded numbers, you will lose that mark. Next, balance the equation. Guys, this one, of course, is a low level, and I was very disappointed with it. This was one of the questions which I was very frustrated about. Yeah, this is actually only a level 4-5, this. Balancing equations should not be that hard. This is not an A-level balance. It's about to get a whole lot harder, folks. I need everyone. I'm going to be doing a lesson on balancing equations, and I will, of course, set you a homework on doing them. Yeah, okay, so let's balance the equation. 3 carbons, 1 carbon. Let's put a 3 in here. Next, 8 hydrogens, 2 hydrogens. Put a 4 in there. Next, oxygens. 2 oxygens. Oh, this is the bit that everyone makes their mistakes on. Yeah, there are 6 oxygens here, 6 here, and 4 here. Total is 10. So it should be 5. And my answer is done. It wasn't even a hard one, folks. The answer is 1, 5, 3, 4, and I was done. Students, I thought you start again after changing something. Yes, and I'm just speeding it up a little bit just to get through it. In reality, I do like to do that process. You'll learn to do this quicker as you practice. Yeah, Anch is right. I tend to say if you change a number, start again. I'm going to show you that just to put that in action since Anch has now done it and make my lesson even longer. Yeah, so 3 carbons, 3 carbons. I've changed somebody. Start again. 3 carbons, 3 carbons. 8 hydrogens. Make a change. I've changed someone. Start again. 3 carbons. Oh, I think my pen may have just died. Oh, I might need to charge it. Ooh, it's going to clean my pen up a bit. It's got stuff on it. There we go. So start again. 3 carbons, 3 carbons, 8 hydrogens, 8 hydrogens, 2 oxygens, 10 oxygens. Yeah, add in those numbers to 5 there, and we were done. 1, 5, 3, 4. Surprised me that students were getting that wrong. Definitely needs more practice. Right, next we're on to moles. Yeah, so level's low again, level 5. It is a level 5 because you're not given the equation. Yeah, and you have to work out relative molecular mass of ammonia, which I don't know what I did wrong. Yeah, and I'll have a chat with you on Hangout sometime. We can look at it. I don't know how you went wrong on that one. So number of moles. Oh, pen's gone again. Number of moles is grams. I'm going to try closing down some of my other things. See, maybe my laptop is struggling a little bit on memory wise. Let's close that since I'm not using it. Let's try that. Number of moles is grams over rams because I've been given grams. So I got given 63 grams of ammonia. So the reason why this is a level 5, really 5, 6, because I didn't give you the formula for ammonia. You had to know it. If you didn't know it, you weren't going to get it right. So nitrogen, of course, is 14 on the table. Hydrogen is 1 times by 3. Add that together and I get 17 for ammonia. I also discovered a lot of students making mistakes because they'd simply thought they'd remembered the MR of ammonia. Wait, can you guys see what you got wrong on the test? Because I can only see the score. Okay, what was that? Is that a Surface Pro? Yeah, it is a Surface Pro, Adam. Flex. I click the link, Emmeline. Yeah, you can click view on the email he sent. Okay, there you go. Thanks, guys. So 63 divided by 17, and I get 3.71 to 3 sig fig. Lots of students lost it because they didn't remember to include that one. If you have problem, try Safari. Oh, I use Google Chrome just because, you know, it all seems to link with everything. This form can only be viewed by the user in the UNIS organization. Emmeline, you need to sign in. I'm not in BSKL. What? It's because you're probably signed into your account through maybe your home email address like Gmail or something. Mol. By the way, the units for moles is mol, but you can also write down moles. They don't really care, which as long as you give the units of moles on mol. Yeah. I had to use Safari. Interesting. Oh, that's interesting. Next. Okay. Next one, we dropped you into a gas moles. Yeah, number of moles equals V over 24. If you're in dm cubed, which I am. If it was centimeters cubed, I'd have to do V over 24,000. If you forgot your equation, you won't be able to do it. Number of moles equals 1.4 over 24, and I'm going to get 1.4 divided by 24. I was in dm cubed, 0.0583 to 3 sig fig mole. There we go. Next, how many moles are in 250 centimeters cubed of? So this one's the badger. I don't quite know what the badger is, but okay. This one drops you into moles in solution. So number of moles equals C times V over 20 over C times V over 1,000. Yeah. So input my data. There's my concentration. So number of moles equals 0.5 multiplied by a volume of 250 all over 1,000. It's over 1,000 because I was in centimeters cubed. Run it through. 0.5 multiplied by 250 divided by 1,000 gives me an answer of 0.125 moles. And we're done. Nice. Moles. Ha ha ha. Adam says moles, Mr. Duncan. Moles and badgers. It's Mr. Loftus's joke. Oh, okay. The badger. Oh my goodness. I have no idea what this is trying to do. Next. Okay. I haven't leveled those. These are all level 5s. Yeah, you've just got to know your equation. All level 5s. Right, we've got a big bit of a jump here now, folks. Question 12 drops us into a level 6, 7. We're suddenly getting much harder. Yeah, because we've now gone into a reacting mass. This one requires me to do a bit of calculations now, so I'm going to rewrite the equation. This is the Haber process. You should have all recognized it. I gave you a fully balanced equation. In A-level, they are not going to do that. You are going to have to write, I was robbed a mark because I put moles. Oh, Adam, you can have it instead of mole. No, that's absolutely fine, Adam. If you were robbed for putting moles, I'll fix that. Are you sure your number was correct? I'll go back and check, but you can have it. Absolutely. No, absolutely, Adam. Take it. Add it. Yeah, totally fine. Next. Right. If you are given 850 centimeters cubed of hydrogen, what volume of ammonia will I make? Okay. 0.125. Yeah, you can definitely have it, Adam. Absolutely. Add that to your score. I'll add it to my score mark as well. Fine. Because moles is actually allowed. MOLS is also allowed. They don't really care. Amazingly. Right. It's a reacting mass question using gases. So in any reacting mass, guys, there are 3 steps. Step 1, get to moles. Find moles. Yeah? So we do find moles of this guy. Number of moles is V over 24,000. Why 24,000? Because I was in centimeters cubed. 850 divided by 24,000 gives me 0.0354. Now, guys, I have kept the real number on my calculator. 0.03541666666. I have kept that on my calculator. Step number 2. I didn't scream like a girl. Step number 2, use mole ratio. Yeah, there's a mark for this that's so commonly lost. The ratio is a 3:2. Yeah, so it's a 3:2 ratio. How do I get from 3:2? I divide it by 3 to get me to 1, and then I times by 2 to get me to 2. So I'm going to do the same thing to this number. These are my moles. Use the mole ratio. So I'm going to divide it by 3. On my calculator, I've kept it. Divide by 3 times by 2. And I get 0.0236. But I've kept the real number on my calculator. 0.023611111. I now need to step number 3. Step 3, get out of moles. It asked me for volume. I need to reorganize this. Bring that over there. Number of moles times by 24,000 equals V. I'm going to multiply that by 24,000. I've kept the number on my calculator, and I get a final answer of 567 to 3 significant figures, centimeters cubed. And there's my answer. Not easy. Talk about a massive step up there. Guys, that's not a level 6. It is a solid 7. Solid 7. Next, right, I can get rid of all the working for that now. Yeek. Let's get rid of all the working out so I can do the next one. If I'm going too fast, just pause the video. I'm going to be reteaching you this anyway, folks, so don't worry. Yeah, so don't worry. Next, right, question 13, another level 7. Another solid level 7 here. Right. So we're now going another equation. Let's rewrite that out. Boric acid. Ugh. I wonder how many people were like, what the hell is boric acid? But you should have been able to figure out what it was. Yeah, and I gave you, once again, a fully balanced equation. You're going to have to make these, folks, at A-level. Yeah, these you're going to have to work out. So it says in the question, I am given 25 centimeters cubed, that's a vol, of boric acid, and it reacts with 18.3 centimeters cubed of sodium hydroxide of concentration 0.18 moles per dm cubed. There's a concentration. I've got everything I need for moles. What is the concentration of the boric acid? Oh, sir, can you get the mark if you put the answer in dm cubed to question 12? Ooh, the question didn't specify. Yes, you can. The question didn't specify. Did you actually give the units, Hermione? Did you write down on your answer dm cubed at the end? If you did, you can have it. If you didn't write dm cubed, then no. Yeah. Step 1, get 2 moles. Right, there it is. Number of moles is C times by V over 1,000. C is, so number of moles equals 0.18 multiplied by 18.3 all over 1,000. Number of moles equals 0.18 times 18.3 all over 1,000. And I get 3.294 times 10 to the minus 3 moles. Right, kept the number on my calculator. Oh, no, I didn't. So, Hermione, then no. Good. Thanks for being honest. If you're going to give a different number and that's outside of what's expected, you must be giving your unit. Yeah, I expected centimeters cubed. Everyone should really be including their units in their answers. You will be. I will train you to do that. This is really a test on the math skills rather than the unit skills, so I'm not particularly worried. But that one, not going to give you. So the ratio, step number 2. This is step 1, get to moles. Step 2, use the ratio, and the ratio is a 3 to 1. I need to divide that number by 3, and I get 1.098 times 10 to the minus 3. Right, step 3, get out of moles. Reorganize. I want concentration. This is why I don't want you using triangles. If I see triangles in my lesson, I'll be sad. Number of moles times 1,000 over V gives me C. There's my moles. Times 1,000, get to the 10 to the minus 3, divided by 25. And I get a final answer of 0.0439 to 3 sig fig moles per dm cubed. We're done. I've made a mistake there. It should be to the minus. Yeah, it's not minus. We'll do that later on. Don't worry. Okay, there we go. There's my final answer. Yeah, I like it. It was another reacting mass, but that's a titration calc, by the way, folks, from GCSE. The titration. Next. Reacting mass questions. Anyway, next. Right. Okay, guys. This jumps to a level 8. So the reason why this is a level 8 is you're given grams and you want the volume and give it in dm cubed. That means I've got to use 2 moles equations. Can I just point out, this is actually a level 8-9, and actually is the first example of a question that's actually at an A-level level. Yeah, this is actually out of A-level, because at GCSE, they don't tend to mix the moles equations. I pressed 2 instead of 3 and didn't check it. So easily done. Right, where's my equation? 2 potassiums react with 2 waters to form 2 potassium hydroxides and hydrogen gas. This experiment would not be done because it explodes, of course, but I've 92 grams. This would be an epic explosion, guys. It would be a wicked demonstration. Very expensive, wicked. Step 1, get 2 moles, grams over rams. What does potassium weigh? Potassium weighs 39. 92 divided by 39, and I get 2.359 moles. Step 2, use the ratio. It was 2 potassiums to 1 hydrogen. Divide it by 2. Yeah, divide that number by 2. Gets me to 1.179 moles. Step 3, get out of moles. And it wants me to have a volume in dm cubed. Number of moles is V over 24. Reorganize it for volume. Bring that over. Times by 24 will spit me out in dm cubed. Multiply my answer on my calculator, which is actually 1.179487179. Yeah, I'm going to now multiply that by 24, and I get an answer of 28. 28.3 dm cubed. Woo! There's my answer. Amazing. Doing well. Doing well. Getting through them. Next. Right. Guys, year 11. This was a disaster. This was, for me, probably, this was more upsetting than the balancing of equations. Actually, was it? No, it's not. Balancing equations is worse. But guys, what a mess this was. I was staggered at how many of you cannot remember how to do empirical formulae. Really upsetting. Come on, year 11s. We will redo it, don't you worry. We will redo it because they do get harder at A-level. But flipping it, guys, not impressed. Compound Y contains sodium and oxygen. Sodium is 59%. Oxygen is 41%. Right, now, since this adds up to 100%, I can do a really sneaky trick. Here are the steps to empirical formulae. Percent to mass. Yeah, step 1. Percent to mass. Just change the sign. 59% becomes 59 grams. 41% becomes 41 grams. Step 2, mass to moles. Grams over rams. Now, in empirical formulae, we are counting atoms. Yeah, we're counting atoms, not molecules. We want to work out in a formulae, oh, what a mess that was. NaX, Y, no, O, Y. We are counting atoms in a formulae. Remember, the molecular formula is the actual number of atoms of each element in a compound. The empirical formula, the simplest whole number ratio of atoms of each element in a compound. We're counting atoms. It's in the definition. So what does sodium weigh? 23. What does oxygen weigh? 16. Convert them to moles. 59 divided by 23 gives me 2.57 to 3 sig fig, but I'll keep it on the calculator. It doesn't. This is actually one of the few times when keeping on the calculator doesn't matter. Because it's a whole number ratio, it doesn't matter if it gets lost in that tiny detail. Won't make any difference. 41 divided by 16 gives me 2.56. Divide them all by the smallest. 2.56 divided by 2.56. 1 and 1.01. The answer is 1. So my final answer is NaO. That's it. I was going to write 1 and 1, but you don't need it. There's my formula, guys. We're done. Yeah, that was very upsetting. By the way, step 3 is divide all by smallest. Yeah, there's your steps. Percent to mass, mass to moles, divide by the smallest, divide the ratio. Yeah, it's a nice rhyme. It rolls up the tongue. So, final answer there is NaO. Isn't that interesting? It doesn't actually exist, by the way, in nature, that one. There we go. NaO. Next is my final answer. Okay, another empirical formula, but so if people couldn't do 15, they couldn't do 16. This was a mess. Compound Z contains 85.7% carbon and the rest hydrogen. Right, first step, this is harder. First step, 100 minus 85.7. I've got 14.3% hydrogen. That would be the first thing I've got to calculate to get a mark for that there, folks. That would be 1 mark at A-level. Right, change them to gram signs. 85.7 grams, 14.3 grams. Change them to moles, over 12, over 1. Well, that was easy. Yeah, 85.7 divided by 12. No, yeah, divided by 12. Gives me 7.14. Divide them all by the smallest. Yeah, divide them all by the smallest. 7.14. 7.14. 1 and 2. Final answer, CH2. But I'm not finished. And Ant is about to get annoyed. Yeah, because he put 4. The problem is, I'm not done. That's not the question. The question then says, the relative molecular mass of Z is 56. What is the molecular formula? This is the empirical, the simplest whole number ratio. We want the real one. We want the molecular. What is the actual number? Well, the actual mass is 56. The actual thing weighs 56. What does the simplest one weigh? 12 plus 2. The simplest version weighs 14. Well, how many times bigger is it? 56 divided by 14, and I get it is 4 times bigger. So the real answer is C4H8. And I'm done. There's my answer. What a mess that was, year 11. I will redo it. Don't you worry. Everything will be retaught. The ground up. Like the roll of the R there. Next. Question, by the way, nice to level them. Yeah, the empirical formula here, that drops, you're going to be shocked at this. That one drops down to a level 6. And then the relative molecular mass pulls it back up to a level 7. Yeah, just like, 7, 8, really. Yeah, that was a level 7, 8. And she just put a big number 4 in front. Gutted. Gutted. Next. Question number 17. How are we doing for time? What time was this lesson meant to finish? No, I've got 10 minutes. 10 minutes for 4 questions? Never going to happen. Okay, so in industry, 1.8 tons of HCl is made per hour in a continuous process. What mass of chlorine is used each day? Give your answer in tons. Right. H2 plus Cl2 goes to 2 HCl's. Right. In industry, 1.8 tons, and it's asking me to give it out in tons, so I'm going to leave it there. I know I shouldn't really do that. Yeah. So I need to do grams over rams, folks. Change that to grams. Yeah. To get it into kilograms, that would be 1,800 kilograms, or 1,800 and 3 more for grams. Wow, I've got 1.8 million grams. Divide that by HCl. What does HCl weigh? 1 plus 35.5, so over 36.5, since it's hydrogen 1 plus chlorine of 35.5. Yeah, 36.5. 1, 8, 1, 2, 3, 1, 2. I think that's 1.8 million. Yes, divided by 36.5 gives me 49315. Yeah, but I obviously know that's more than 3 6 figure. I'm going to keep the number on my calculator. Yeah, how much chlorine is used each day? The ratio is 2 to 1. Divide the number on my calculator by 2. Divide it by 2 gives me 2, 4, 6, 5, 7. It doesn't, even though it actually be 8, but I haven't rounded yet. Kept the number on my calculator. Right now, this is the chlorine needed in moles per hour. Yeah, and then it says per day. Times that by 24. You can actually do the times by 24 at any stage if you like. Right, so if times that by 24, I get 591,781 every day. Right, now I need to put that into tons. Let's convert. I'm going to multiply that by chlorine's mass. Rearrange grams over rams. I'm still confused what 3 significant figures was in question 16. There wasn't any in 3 6 figure. Right, it shouldn't have been there. My bad. Shouldn't have been there. Thanks, Oliver. Thanks. Right. Times that by the mass of chlorine, which is 36.5 times 2, which is 71. Times that by 71, and I get that. Right. That's in grams. Divide that by, and I need it in tons. Divide that by 1,000,000. I will redo these questions. I realize I'm rushing it. 42. I get 42.0 tons per day. There's my answer. I realize I'm running out of time, folks, and I want to finish this in a single setting. Yeah, a single sitting. So 42 was the right answer. I went very quickly there. I do apologize since it was a hard question. Next, number 18. Right, a student, sodium plus, so do you have to convert it back and forth? No, you don't actually. Well, it actually, Emily, it's a bit confusing that on EdXLs. You should have to do that in your, yeah, you're meant to. Yeah, it's a bit of a nightmare, I know. The mark would be for the moles being the correct number. What a nightmare. Plus oxygen. I'm running out of time. Na2O 4. I'm actually going to do this in 5 minutes to go. A student heats up 8 grams of sodium in a crucible and produces 9.3 grams of sodium oxide. What is his percentage yield? Percentage yield is a practical base. What that's telling you is that's not 100% output. Yeah, not 100%. What should he have gotten? Right, reacting mass. Step 1, get to moles, over 23. 8 divided by 23 will get you the moles of sodium, 0.348. Kept it on my calculator. The ratio is 4 to 2. Divide it by 2. Divide that number on my calculator by 2, keeping it there. 0.174. Kept the number on my calculator. Multiply that. Get out. Step 3. Get out of moles. Multiply by the MR. 23 plus 23 plus 16. That weighs there 62. My pen's running out. 62. I need to do the calculation again because I've lost it on my calculator. 8 divided by 23 gives me that. Divide that number by 2 gives me that number. Multiply that by 62. What he should have made 10, multiply that by 6, multiplied by 62. He should have got, as a correct output, 10.8 grams. Keep it on my calculator, though. But what he got was 9.3. 9.3 divided by answer times 100. His output was 86 to 3 sig fig. Did it say it? 86.3% output. I know this is hard, folks, and I'm rushing it a bit. I apologize for that. And if, by the way, you guys can leave on the dot, yeah, go to your next lesson. Isn't it lunchtime? Is it lunchtime next? Because then I don't really care. I'm rushing this and I don't like it. Yeah, it's lunch. You can stay. Yeah. So, guys, I ran a reacting mass calc. I ran a reacting mass calc to work out what he should have got if he'd done it perfectly. But he didn't get that. Percentage yield is a practical test. It is the prac output over the theoretical output times 100 to see how well he did it. Yeah, and that'll give me the percentage yield, which is that number there. Right, next. Tricky though, not easy. Yeah, let's go to the next one. Right, next. Question 19. 3 grams of calcium. Calcium chloride, hydrated calcium chloride is heated. It's an empirical formula. This is a water crystallization question. So I'm going to split it into 2: calcium chloride and water. And I'm trying to find X. I need to count them. Count the number of X's. Well, I had 3 grams of the whole thing. I had 3 grams of hydrated, 3 grams of this entire thing, and I heated it. Add heat. And what happens is the water leaves. Yeah. And what that means is what I had left is 2.02 grams of just, this all disappears. So I end up with just that. So I've got 2.02 grams of that. What was the difference? 3 minus 2.02 gives me 0.98 grams, 98 grams of water. Right, we need to count them. How do you count particles? You count moles. Yeah, water weighs 18, we know that, so divide that by 18. What does calcium chloride weigh? Calcium is 40 plus chlorine at 35.5 times 2, 111. Count moles. 2.02 divided by 111 gives me 0.0182. Next, 0.98 divided by 18 gives me 0.0544. Divide them all by the smallest, which is that one, 0.0182, 0.0182, and I get 1, and that number divided by 0.0182, and I get the answer is 2.99. The answer is 3. X equals 3, and I'm done. Last question, with 1 minute to spare. I'm not going to make it. I'm not going to make it. Oh, last question, folks. The hardest question of the bunch. Yeah, this is a full level 9. In fact, this is actually a C graded GCSE. It's an excess reagent calculation. I've given you 2 moles. Right. I will reteach you this, don't worry. Equation. Lithium plus oxygen goes to lithium oxide. Balance it. Okay. I've got 40 grams of lithium and 30 grams of oxygen. What that means is one of them I've got too much of, but who is it? First thing you need to do, step 1, get to moles. Over lithium weighs 7. Over oxygen, 32. Oxygen is 16, but it's in a pair. So 40 divided by 7 gives me 5.71 moles of lithium. Next, oxygen, 30 divided by 32 gives you 0.9375 moles of that guy, right? It appears as though that one's going to be in excess, but we need to check this. We need to check it. I'm going to cover somebody up. Cover it up. Right. I'm going to cover him up. The ratio is a 1:4 in the equation. 1:4. Right. So how much did I actually need? I needed 4 times that number on my calculator, times by 4. I needed 3.75 moles. How much did I have? I had more than enough. So this one is in excess. I now ignore it. Yeah, I now ignore it. And I now use these moles to work out this guy. Ratio is 1:2. So 0.09375 times 2 gives me 0.1875. Multiply that by the weight of lithium oxide, a rearrangement of grams over rams. Lithium is 7 plus 7 plus 16. I get 30, times that by 30. So 0.1875 times by 30, and I get an answer of 5.63 sig fig, 3 grams, and I'm done. Oh, and we made it. No, 2 minutes over. What a nightmare. It's hard, isn't it? Sad. Right, back to here. Guys, it's been a roller coaster ride. And do you know what? In a lot of ways, I wasn't really intending on trying to explain all of these questions through. I realized that I've got to go back and reteach this. Sig's so annoying. I know, Adam. I know. I'm going to be reteaching you all of these processes anyway with A level in mind. So I'll be pushing you the extra miles, getting you to do more challenging calculations. The only thing this is about, guys, is about practice. I need you guys to be doing it. I will be starting our very first calculations lesson, Chemistry 101. Next lesson, I believe that's Monday. Yeah, first lesson on Monday, guys. I will be doing it on YouTube. I will see you guys there. A-level calculations starts then, Chemistry 101. The form says the answer is 56.3. Oh, what have I done? Have I done something wrong? I've done something wrong. I've missed something. I've missed something. I've missed something. That's pretty sick. Have I made a mistake? It's totally possible. Totally possible. I should have actually probably made more than that, to be fair. I don't know. Yeah, I think it should be 56.3. Or have I done something wrong? Hang on a minute. 0.1875 multiplied by 30. That doesn't make any sense, does it? 30 divided by 32. 30 divided by 32 times by 2. 1.8. There it is. There's my mistake. 1.875. My apologies. Thank you for catching it, folks. No, I think you did say 56.3. Should have been. No, I've made a mistake. Times by 30. I wrote down the wrong number. So 30 multiplied by 1.875. My mistake. 56.3. My bad. There you go. Even I made a mistake. It does happen. I am fallible. There you go. Easy fix. Thank you guys for helping out. Right, guys, I will see you guys all next lesson. I hope you guys have a lovely long weekend or a lovely weekend. I'll see you all soon. See you later, guys.